Hi everyone. As you may know, the beam can now record and reproduce raw RF codes, which means that as long as the device works within the right frequency range, in theory we can reproduce almost any code for any kind of device, with the exception of rolling codes that change all the time. So this is pretty cool. Learning RF was a bit of a challenge. In order to tackle it, we've created a plugin for VoxCommando that lets us record the RF that's coming in from the beam and analyze it and work with the numbers that we get. Some of you have already seen the first generation of this plugin, and what we have now are some extra tools for learning and analyzing these codes. So these are familiar. The lock minimum value would be the minimum number used to indicate the beginning of a new sequence. And noise is important because when there's no remote being used, there's still a lot of noise being recorded, so we want to discard anything that's got a really short code because that's noise. Now these settings are new. This is used as the plus or minus range to indicate that two numbers are the same. So if it records a 51 and then it records a 53, it's going to say, oh, okay, these are probably the same number because they're within 10 of each other. And then a 49 comes along and it's going to say, yes, this is still the same number, and it'll average them all out over the length of the whole sequence when creating the compressed code. The clear button, if enabled, means that whatever is in the table will be discarded anytime you start learning a new code. Once you've learned a code, you may want to turn this off and start recording different buttons and making notes about what they are. And then we have other tools down here for analyzing those codes and as though they were a protocol, trying to detect what number sequence they're generating. So I'll do a quick test with my Intermatic remote. This is a 315 megahertz light switch remote. So let me explain a bit what we're seeing here. First of all, this is the raw data that's coming back from the beam, completely unedited. So it basically starts recording until the buffer is full, and then it sends it to VoxCommando, which starts to analyze it, again using these values. And the noise value is actually used exclusively by the beam. If it runs into noise too early in the sequence, it'll just empty the buffer and start over again until it gets a noise-free signal that starts with this lock minimum. Now you can see here that we've got the numbers are subtle, but these are all the same color, and that's because their compressed codes are all identical. Really, if you look at these other ones, their compressed codes are also very similar. It's just that the numbers that we have are slightly different. C and D is 25, here it's 26. So basically these are the same numbers, just slight differences in the values that were recorded. And you can see by the length here that we've got a lot of them are 50s. That means that probably the only codes that are valid are the ones that are of length 50. Now we can click on any column and sort on that column. So if we click on length, we can go and select the ones that aren't the right length and delete them by pressing delete on the keyboard. Obviously this is a clean signal that we're getting, and we can now analyze the sequences. And what that does is it starts looking at number pairs and turning them into binary, and then it converts the binary into hex. So these settings, the intro value refers to this first number in the sequence, which is not part of the binary data. This is the number that indicates the beginning of a new sequence or the end of an old sequence. So by setting this intro value of 1, it means that we're not going to look at the first number. Other protocols might have a number of other numbers at the beginning that are also not part of the sequence. It might be a 500 and then 1000 and then go into the binary sequence. So then you would increase the intro length to 2 to tell it to ignore the first two numbers in the sequence. And then we have currently two methods of determining the binary values, which is looks at number pairs and has different rules for deciding whether a number pair represents a 0 or a 1. You can look at the code yourself here. So we skip the intro of 1 and then we look at the first pair of numbers. Okay, here the first number is significantly less than the second number, so that's going to be either a 0 or a 1. Then the next pair, the first number is significantly larger than the second number. That's going to be a 0 or a 1. Whatever it is, it's going to be the opposite of what this one was. So in this case, we're using the rule that if the first number is significantly bigger than the second number, consider that a 1. So in this case, this is not true, it's a 0. And you can see over here that we have a 0. And in the next pair, it does match our rule. The first number is more than twice as big as the second number. That's a 1. So you might think that these two things are just the opposite of each other. So what difference does it make? But it's not true. You'll see there are different number patterns that are used by different protocols. So if I'm going to select clear, and then I'm going to learn an X10 code. Now this is where you see why these tools are handy. The X10 remote is a 310 megahertz, not 315 megahertz, and the signal strength is not very good, so we have a lot more noise and inconsistency. However, you will see that we do have definitely patterns. Most of the time the lock is starting with a number of almost 500, and you can see other cases where the lock is not starting with 500. This is noise. So we can sort on length. We can look down here at these ones of length 66 and look at this pattern and see, oh yeah, this is definitely looking like a consistent pattern that we're getting over and over again. So I can delete now anything that isn't of length 66 based on the assumption that that is the correct length for this X10 protocol, and I happen to know that this is true. Again, we obviously have an intro of only one number, because after that the numbers start to repeat. If I click Analyze Sequences, we can see that our binary values are all zeros, so that's obviously not very likely that they're just using all zeros for their code. And if you look at the way that these numbers are, go back to the first two numbers and look at our rule. Is the first number more than twice as big as the second number? No, it isn't. 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 But obviously there's a difference between these two things. Now if we try our other rule, is the second number significantly bigger than the first number? No, it isn't. Yes, it is. So this should be a 1, obviously. Now that we've chosen this method, if I click on Analyze Sequences, you'll see that we're getting not only numbers, but we're getting the same number over and over again. So we know this is a good code. Now we know the basic structure of an X10 code. Another new thing that we have here is a send button, so you don't need to double click or anything like that. You just click on send and it'll fire that code off for you to test with your device. Now what I'm going to do is unclick clear, and I'm going to record the name of that button, which was, let's see on the remote, we were on house code B, and that was B1 off. Delete all the extras, and I'll try to learn B2 off. So now, using what we've learned, we can discard anything that isn't a 66. And to delete these, I'm just using the delete button on my keyboard after I select them using the row selectors. You can see it looks similar. This is a slightly messier code, but it's probably still valid. It's just that it wasn't rounding the numbers quite. There was a bit more error between the numbers. So if I analyze the sequence now, you'll see, yes, we're getting the same code for all of them. Very good sign. And we're also noticing that the first 4 alphanumerics in the hex code are the same. And if you learn a bunch of codes, you'll see that that's always true until you change the house code. The house code B is giving us this number. If I change to house code A by turning this dial on the remote, B2 on that we learned, I'll delete these duplicates and I'll record A2 on. So I've changed the dial on the remote to A, and now I'm going to press 2 on. I've only got one code that looks valid. You see how much error we have with this remote. But it looks like it's probably good. Now if I analyze, I think it's an error still. I'm going to try again. I'll leave it there. A2 on. Oh wow, got lucky there. Let's analyze these. Okay, this is definitely correct. And you'll see that the first 4 digits now are different. That's the house code. This is the button code. I believe that I may have pressed the wrong button, but I've learned that the house code is always the same. So if you're pressing any button for the house A, the first 4 digits will be the same. And the second 4 indicate the button. So no matter what house code you're on, if you press A1 off, it'll always produce the same number sequence here. Anyway, that's it for this demo. We'll be adding more tools later for storing these numbers or maybe dragging codes into the VoxCommando macro editor or whatnot. The one last thing I'll point out is that because this is a proper table now, you can select columns like this and copy and paste them into Excel, for example. So you could select all of this data and hit Control-C, and that's one way that you can keep your numbers, work with them, copy and paste these into a map table, things like that. So thanks for watching, and look forward to hearing your feedback.